Hello, we have already finished with relations. Now for you, I am bringing functions. I do hope that you have done the problems related to relations. We did few of them and the rest you can do yourself. This is homework, right? And now we are going to start with functions, which is one of the very powerful and very important part of your syllabus, right? And it's, of course, remember, it's little difficult as well, rather I must say confusing, but don't worry, we'll try to make it easier for you, right? So let's start with functions, right? First, let me write the definition, a formal definition. Definition varies as person to person, so you might find little different definition in the book. What I am going to give you might vary in the wordings, but that doesn't make any sense. Remember, its meaning should be always the same and you should understand the correct things. That's all. So I am writing the definition like this: for any non-empty set A and B, the rule, better we write a rule which, right, assigns a unique element, right, from set B to its element of set A, right? So if you can define a rule by which every element of set A is related to a single element, unique element of the set B, then that rule is known as the function, right? So we'll be coming to the symbolization. Just wait for it. First we'll see the schematic view, rather I say a visual aids, which will make the things clear, and then we'll transcript everything in the board, right? Then it will be easy for us to understand. So I'm bringing that same model, right, which I used for explaining you the relations, right? What I am holding in front of you is the two non-empty sets. This is one which I want to give name as A. This is B, right? This one is A, this one is B. It contains 5 elements. It contains 4 elements. Now, by the rubber band, what I put between these elements, it shows that this element is related to that. Now in terms of mathematical language, I could say that image of this point is this. Now just see the definition. Do you find these elements are related here by any chance? No, because there is no rubber band connecting them. So this is not a function. This is not a function. So I have to make it in such a way that elements these are also related to one single element of this side, right? Let's do the modification in front of you only, then you will understand it very quickly, right? So let me remove this, and suppose I have associated this element with this, right? Let me remove this and associate this here. Now what you say, is this a function? Is this a function by that rule? No, still there are two elements which doesn't have any relative this side. But function says you have to get every element related to a single element this side, right? So we have to add more rubber bands in order to make the function. Say this is related to that, right? This element has a image here. You might be now thinking, I have an image already here. No, that's not a lookout, because I only need to see this, whether this has a unique image or not. If this is the image of someone else, I don't have to bother. Image of this is unique or not, that you see. Whether there is only one rubber band coming out, if there will be two, no, that is not allowed. So now still it is not a function. We have to complete one more. Let me relate this green to green, right? So now just think, is this a function? Just you think, is this a function? Yes, that is a function. It has unique image, it has unique image. This image is unique, this image is unique, this image is unique. So this is function, right? So this is what you have to think, that every element of this is related here. First thing. Next, one more thing. I'll just modify this to explain you. Suppose I remove this and I have said that these three are having the same image. This is allowed? Yes, it is allowed, because from here you see it has only one image, that's all. And here this is the element which is not related. No issues. That is not mentioned over there, that every element should be related. Not at all necessary. Only you have to see whether elements of these are related there or not. Right? Did you get me? So here I got this also as a function. Previous one was also function, where I have related every element here and all are related this side also. This time this is left out. Before I go for the another one, let me try to tell you the definitions of domain, codomain and range. What is same as that of the relation only. Little difference is there. In relation we considered only the elements which are related. If anyone is not related, we did not consider in the domain. But here that question will not come, because every element will be related. Every element will be related. So the left side whole set is the domain. That's the easiest part for us in function. Left side whatever is the set A, that is the domain. Right side whatever is this is the codomain. Range definition remains same. Whatever elements are there having relatives here consisting of the range, that means for this particular function range will not contain this point. Range will contain only these 3 points. Did you get me? If I name them as ABC, range will be ABC. If I name as ABCD, then codomain will be set ABCD. Domain will be 1, 2, 3, 4, 5. I use the same numbers what I use in the relation. Got it? Now little modification I'll do, and I'll write everything in the board. Okay, supposing that I remove this and I do this, will this be a function anymore? Or say completely I remove this. Okay, I cannot remove it from here, let it be there. Will this be a function? No, that's not a function, because this is left out. This is left out. You cannot leave anything here without relating. Number one. Okay, fine. Now suppose this is related. Suppose this is related. And then I do this also, that this is also related to this. Will this be a function? This time too we have satisfied the conditions, every element related. But remember, one condition is overlooked: uniqueness of the image. Now you see the top point, first one. It has an image here. It has an image here also. How did I confirm? Because of the rubber band. Got it? So this is not a function. Why? Because this element has two different images, and which is against the rule of the function. Right? So now let's write these things. About the definition of image, pre-images, everything is same, right? So we'll be writing now the things in a formal way, right? So, but before that, one small thing again I would like to write. Function, how you would like to visualize, right? You consider this as a machine, right? Suppose there is a machine, this is the machine, right? And this is the input. input and here is the output, right? The function is like a machine. You will give some input in the form of variable x, which contains numbers also, and then it will give you some fx, and that fx is the rule, right? Supposing that the rule is here x square, means if you give input x, it goes out to give you x square, right? So this is a function. Now you see how it works. Supposing that you are putting 2 here as an input, you hold your hand like this, what you will get in your hand? It will be 4, 2 square you will get, right? If I put 3, what I will get? 9 I will get, right? Now, will that be a function? Will that be a function? Right? It will be, because you are doing a square. You are doing a square. So if you take the square of a number, do you feel that you will get more than one option as a result? No. So for every input you are going to get only single output. Therefore, this follows the definition of function. So this will be a function. Of course, I did not tell about any domain, any range here, just for understanding purpose, right? Okay, now let's go for the formal ones, right? So you see, a function f from a to b is denoted by y equal to fx, right? Y equal to fx. Actually, this is also the symbolization. This is the rule, right? This is the rule. Function, a function, this is, do not write denoted, it will be little incorrect. Defined by y equal to fx. Here they tell you the criteria how y and x are related. That means input is related to the output, right? The way we define in the relation, right? So this is how we write. Now if I write like this x is known as the pre-image, this is known as the image. But how will I visualize? To make it visualize by drawing a figure, right? That will be easy for us. This is A, this is B, this is the function, right? So if x is related to y, if x is related to y, then this is known as pre-image. Pre-image, right? Pre-image of whom? Pre-image of y. And this is known as what? Image of x. Rather, to make it little more stylish, we can say f image, right? F image of x. F image, why? Because it is the image under the function f. We call a function a mapping also. So under the map f, this is the image. So it is called f image. Now one very important point. Already you have got the idea of relation, writing it in the ordered pairs. That means I am talking about the roster method. If x is related to y, then can I write this function also in the way of ordered pairs like this? Yes, I can. If I have suppose x1 related to y1, I can get the another ordered pair. Just for example, I am taking 2, right? That means the same way we represent relation, we can represent function also. But what will be the observation we should make here to conclude that it is a function or not, if it is given as a relation, right? First criteria, every element in the left side set should be related over there. So when you check the ordered pairs, definitely they will tell you about the first set. just see in the first place whether all the first place elements are placed or not. First thing. Second thing, as this should have only unique image, matlab one image, right? There should not be two images. So you just check, is there any repetition, right? Is there any repetition of the elements in the first place? Because repetition will tell you what? Suppose I have a repetition x1 comma y and x1 comma y1. This repetition will tell you what? Image of x1 is y and image of x1 is y1. That means x1 has two different images against the criteria of function. Did you understand what have I said? If somebody randomly write like this, for a quick example I'll take, right? Say somebody says that there is a function which is, or there is a relation which is written in the roster form like this: 1 2 2 3 2 4, right? And this is a, say, relation from A to B, and A is the set. Here I am writing 1 2, right? And B is the set 2 3 4. Now, is this a function? Is this a function? No rules, nothing is given, only ordered pairs is given. Fine, that is also okay. That is also a rule. 1 has image 2. Okay, there are two elements. I have to only verify whether every element is present or not. 1, 2, every element is present. First criteria is satisfied. Second is not satisfied because you see 2 is present in two places. This says 2 has a image 3. This says 2 has a image 4 against the function's rule. So this relation is not a function. This relation is not a function, right? So one more thing we'll consider. Actually, I am just trying to give you the idea from the roster method, right? I am not drawing the ray diagram. Ray diagram will be easier for you, right? Suppose I have this another one in this only, say 1 2. Okay, one more I would like to write here. A equal to suppose 1 2 3 and B equal to suppose 4 5 6. So 1 4 2 5 and 3 6. Will that be a function? Yes, that's it. That will be a function. That will be a function. Every element is present and it comes for once. That means every element has unique image. So it is a function, right? Can we write the range and domain from here? Yes. The first place elements always constitute the domains. So you write in the form of a set. Second place element, if you write in the form of a set, always constitute the range, right? So both domain and the range are visible from this particular roster method. Why am I explaining you? Because this kind of questions will be given to you, right? These are there in the exercise. So you'll only have to give a glance and just see these two criteria. Repetition in the first place not allowed. All elements of set A should be reflected in the first place, right? Finished. Okay. So here I finish this particular one. Now quickly, what I explained there, I am taking a little more time because this basics should be very, very clear. Don't get bored. Suppose I have these two sets, right? These two sets, and then I have elements. It's not necessary that I should get equal elements. Then I am writing like this. Is this a function? Yes, it will be a function. Your target is to see whether each and every element is related. Whether every element got only one image. Yes, they have got. So it is a function, right? Even if in this side some elements are left out which are not related, no issues at all. This side nothing should be left out. This side, okay. Next, fine. One more figure we'll draw. AB, right? Okay, we use this particular things and we write a name also here. Now this time, right, this time we are going to do this. Elements are here. Is this a function? Yes, this is also a function. Even if I have one element as image of many of this side, that is not an issue. Only I'll see that this element has how many images, how many arrowheads are coming out. One arrowhead is coming out means only one image. So every element are engaged. There are some element left, forget about that. I'll not bother about that. Then next, is this a function? This is a function, right? This is also a function. Is this a function? Here every element in the left side is selected. First criteria satisfied, but second is not satisfied. Second says every element should have only one image, only one. Here you see, this is having this image, this is having this image, two images. So it is not satisfying the second criteria. So it is not a function. It is not a function, right? Now next, if I have like this, will that be a function? This is also not a function. Reason? This time the first condition is only not satisfied. See, this is the element which is set idle. It doesn't have any relative in the other side. That is also not to be there. Am I clear? So you have got example of two functions and two things, two relations which are not functions. Now from the above ray diagram, you can make sure just by giving a glance whether it is a function or not. You just check. First thing to already you have to check okay, all the elements are engaged or not. One glance. Second glance, no need to see every unique elements. It will take time. Just you see, is the figure containing any divergent arrowheads? If it is, it can never be a function. Divergent arrowhead matlab from one point more number of arrowheads going out. If from 2 points convergent arrowheads are going on like this, it's a criteria of function. That's not a problem. So what is the thing you have to see? Left side no such element should left out. No bindi should be left out like this if you consider as element, and then all arrows should be convergent. If divergent arrowheads exist, even one, right, then it will not be a function. So that's the idea by which arrow diagram helps us, right? So this is all about the definition of function. And domain, codomain, etc. already we have discussed. So I think I'll not write it here. But anyway, I'll be giving this as a chapter note. You will find there all these things over there, right? So there is absolutely no need to worry about the notes here. But please try to do write from your side also. Even if you get a note, do not just paste whatever I am typing or I am giving you. You write it yourself. That is a practice, right? Okay, so we have got the idea of functions, we have got the idea of domain, we have got the idea of range, we have got the idea of codomains, right? Very nice. Now, there is a very important point. The important point is that we have something called a real function and we have something called real valued function. We have something called real function, we have something called real valued function. What are real functions? Real functions are those whose domain and codomain, right? Domain and codomain, I have written the small symbols, short symbols, are subset of real number. I have written subset means sometimes they may be equal also, that's not an issue, maybe the whole real number, but they may be a part of real numbers. Then both if they are, then it is real functions. But if I say real valued, then we do not have any idea about the domain, right? We only know that codomain is a subset of R, right? So far we haven't started with the complex numbers. So if in the domain I keep the complex number and range I keep the modulus, you will come to know about this in the complex number chapter. So I am telling now only, so you can easily relate at a time. Then it will be a real valued function. Pre-images will be complex number, whereas images will be real numbers. So that gives you a good example of real valued function, right? So this you try to read very carefully and see, observe clearly. Next, one very important thing, that in class 11 or 12 by default we will study only real functions, means domain as well as codomain will be either real numbers or subset of real numbers, right? So there is no doubt, there is no problem, right? Now of course I say no problems, but there is a big problem, because in finding the range and domain there are many questions. Now let's just see a small trick just to proceed ahead. When we talk about the domain and the range, definitions को गोली मारो अभी. I am giving you the way how you should see the domain, right? Domain how you will see, because whenever you are going to work with the function, your proper definition never helps you at the beginning. You need the tips. That tips I am going to give you. Domain means all those elements, right? Domain means, see, I am not writing a very formal words, or rather I should write, otherwise I may be criticized. Better I write all set of, I write like this, set of all those elements, right? In the left side set, left side set matlab F from A to B, if I write, I am talking about set A, where we can find value of fx finitely in B, right? In B. B is the right hand side set. So sometimes what happens, if B is the complete real number and we find some value of x where fx I am unable to find finitely, so that x will not be belonging to the domain, right? Am I clear to you? So this whole thing we write as what? There is a word, mathematical word we use, that domain means the set of all x where function is defined, right? Function is defined. The word what I have written here, defined, means that, right? If at the beginning I am not told that this is a domain, I am only told you find the domain, means where the function will be valid, that you find, then I have to say like that, that this function is defined at this point. Now I will go for a quick example so that it will be clear to you. For example, if suppose I have given you a rule means you think that a machine, right? Your input is x, this is the input, this output is 1 by x. If you give x, coming out as 1 by x. If you give 2, half, 3, 1 by 3, right? 0, 1 by 0, is 1 by 0 is defined? Not defined. What does that mean? If now I am trying to find what is the domain of this, भाई जीरो नहीं आएगा, because if you give the input as zero, machine will show you error, right? Like the calculator. Try to find 1 by 0 in the calculator. There is a ulta E, right? Mirror image of capital E. Error, right? So that's the thing. Error should not come. If error comes, that should be avoided from the domain, right? That should be avoided from the domain. That will not be a part of the domain. Got it? So here, if I ask you, write the domain for this. So it's all real numbers except 0, because at 0 you cannot find 1 by x. So domain will be real number minus 0. Am I clear? So I do hope that I am clear. Now consider little more, a small example again, right? See, I'll be discussing more examples, more formal problems when we get the clear concepts, right? There is something called algebra of functions also that I have to discuss. But first, we'll talk about this domain, right? Little more so that you get a very clear concept. Suppose I give you x minus 1. Fx equal to x minus 1. What you would say? Right? Domain. I need domain. What you will say? Now you see, now you have got an idea. If I have a fraction, then that fraction will not be defined if I get in the denominator 0, right? So you have to avoid the 0. You have to avoid the 0 in the denominator. So now to avoid the 0 in the denominator, what number should be avoided? It should be 1. Now from the whole real number, if you avoid 1, if you keep 1 aside, you quarantine, right? You quarantine 1, ja bhai dur bhag. Then the remaining real numbers will be of work, that will give you some values, right? This time 0 will not be quarantined, right? So here, what will be the real, what will be the domain? Domain of the function will be real number minus 1. See, I am discussing very small questions at the beginning. Suppose I give you x plus 1. Which number is to be quarantined? Very clear. Minus 1 is to be quarantined. So your domain is this. Did you get me? I hope you are clear. चलो इसको थोड़ा सा और आगे बढ़ा लेते हैं. इतना छोटा में हमको सेटिस्फेक्शन नहीं आ रहा है. ओके, सपोजिंग दैट आई गिव यू x minus 2 and x minus 3, 1 by this. किसको क्वारंटाइन करेंगे? Which number will be quarantined? 1 is 2 because it is going to give you a 0 in the whole denominator. Another is 3. So पूरे real numbers say, from the whole real numbers, you are going to remove which one? You are going to remove 2 and 3. You are going to remove 2 and 3. So this is the domain. Is that very clear to you? So see, this is one of the important aspect which will be taking care when we will find a domain. When fraction comes, denominator should not be 0. It should be avoided. It should be avoided. And you avoid by removing those numbers which makes the denominator 0. Let us quarantine them, right? Okay, one part done. Now let's see what another type of functions or conditions may come. Okay, very nice. Fx equal to root over x, square root of x. Now just I am asking, go on putting values of x. Let us trial. I ask you to find f of 4. Can you find 4? F of 4? Yes, f of 4 means root over 4. I'll be getting a value 2. Hurry. Why not minus 2? That's the thing. That confusion you have to remove. If I write it like this, always it includes the positive values. If I say find the square root of 4, positive values, right? If I say x square equal to 4, what are the values of x? Then x equal to plus or minus 2. Got the difference? Square root is always positive. Square root is always positive. So this is always positive. And by chance, if I want negative, I'll write negative here, right? Now you tell what x I am allowed to put so that I can find this negative to automatically will come square root of 4. Just try to think, modify your imaginations. I can put square root of 4, fine. I can find square root of 3, can I find? Yes, I can find. I may not be able to find it exactly, but root over 3 is there and that is a real number. That is a real number, right? What about 0? Can I find the square root of 0? Yes, that also I can find. Minus 1? No. Did you ever get any real number whose square is minus 1? Never you got, right? So that means once it is the case of square root, you have to avoid which numbers? Those which are negative. Those which are negative. Because you cannot find the square root of negative numbers. Quarantine the negative numbers. So here your domain will be what? All positive real number including 0. Including 0. Right? So here is the idea. चलो थोड़ा और इसको मॉडिफाई कर लेते, इसी को fx is equal to x minus 1. Now you tell whom you will quarantine. किसको क्वारंटाइन करोगे, राइट? सिंपल है, वेरी सिंपल. हम लोग उसी को क्वारंटाइन करेंगे. विल क्वारंटाइन दोज ओनली which will give us x minus 1 as a negative value. That means how we will write? X minus 1 is negative. When they are negative, it will be negative when x is less than 1. Right? That means from the real number set, I have to kick all those numbers out which are less than 1. Then the remaining will be the domain. So when we see the number line, 1 is here, and if I talk about the less than 1, left side you have to come, and already in set theory you got the interval. When I write an open ball means there is a gap, blank, then it tells you that I should not consider 1, this side I will consider, right? So this I do not need. Right? I do not need. So I need right from 1 towards infinity. How would I generalize it? Open interval 1 to infinity. So for this one, your domain is 1 to infinity. Have you understood this? Have you understood this? One more I'll take, but I'll not take here quadratic. I'll take it in the next class. First you make sure that you understand this, right? One more small problem we'll be doing and then we'll see, right? Just reversing the order we'll see. Suppose I write like this, instead of x minus 2, 2 minus x. The story is very much same. What is the story? What is the story? Here also you have to choose those particular value of x such that quantities inside the square root becomes positive. That means quarantine those numbers which will make 2 minus x a negative quantity. So if 2 minus x is negative, I'll be getting like this. So taking x to that side, ultimately x is greater than 2, right? That means those numbers which are greater than 2 are problems for me. Quarantine them. right? So if 2 is here, it is open ball. This side I have to avoid. So here my domain will be from infinity to up to 2. Right? This is the domain. Okay. Now, is there any other option to visualize this? Because I have now started from the negative options. Right? Those where it is not true. Right? Where it is negative. Can we think in the reverse direction? Now we can think. Because of this only I did in the negative directions. You have gathered now enough information. Whenever something is there in the square root, necessarily it should be greater than or equal to 0. Do it, you will get the answer in short. Just say, if instead of doing this, I could have said that I can define fx, means I can find the value of fx for those x when 2 minus x is either 0 or positive, greater than or equal to 0. So what will it give me? This, what will it give me? X is less than or equal to 2. It means 2 and then left side. All numbers are favorable for me. That is minus infinity to close interval 2. Have you got it? Fine. Did you understand that? Okay. Now, with this discussion, I'll finish this particular class. We'll see you in the next, right? What we'll see? One more example of function. Okay. Now we will combine two things. Fraction and the root. Fraction and the root. Two different conditions you have to remember now. Combine them. First condition, fraction में नीचे 0 नहीं आता है. Denominator should not be 0 for fractions. Clearly x equal to 1 is kicked away. Right? 1 cannot be there. Second condition, square root is present. Inside the square root negative number नहीं आएंगे. It should be greater than or equal to 0. Right? So, what conditions we get? We get condition x cannot be equal to 1 and at the same time this should be greater than or equal to 0. Right? In order to get root over x minus 1 worked out, this will tell you x greater than or equal to 1 and this is already saying x is not equal to 1. Combining both, what you will write? X is greater than 1. Have you understood what I am trying to mean? I know I can find this directly by putting greater than or equal to 0. Sorry, greater than 0. But I am not doing because I want to show you that in the same function we may have to use 2-3 different criteria to find the domain. 2 different criteria. Denominator should not be 0 and quantities under the square root should not be negative. It should be positive or 0. Right? By that we have found a domain. So this I can write like this, all real number greater than 1, or if you would like to write this as a interval, how would you write? It is open interval 1 to infinity. Now a very important note before I leave today for this period. Please make sure that you read the books, whatever conditions are given. Read it once from your side yourself. Whatever I explain, forget about that. See that, understand that, and then forget. You read it yourself, then it will be clear. Number 1. Number 2, whatever examples I have taken, do not consider this as a formal answer. Just to get the concept clear, we have taken the questions. For our theoretical approach or the approach in which we do the question for the exam purpose, is entirely different. I should have to add some statements, which I did not do, only to explain the concepts. So when I take up the problems formally, you will definitely get all those statements, right? So now a small task for you, you please clear the definition of function and then do some workout like this roughly, so that your brain will get the information what the domain is. Because once you'll be clear about the domain, then only we'll move on to the range. Range is little more complicated. Okay, I'm not getting you scared, I'm not making you scared, but this is true. You have to use a lot of logic to find a range. Anyway, we'll try to make it simpler for you, but please do support us by reading these things. Bye.